3, 2, 1. Let's go!
I'm a fellow who's from the flatlands of northern Saskatchewan here in Canada, up in Canada. My family were entrepreneurial from the get-go. My parents were both entrepreneurs who moved us to Calgary in the mid-'80s to pursue a better life and some dreams and goals that they had. And I grew up in that environment and saw them work their butts off for 20 years. They had a home cleaning business that did well, and they eventually sold that and got involved in a number of different opportunities that us kids kind of got dragged into. Honestly, some of my fondest childhood memories were being part of what they did to accomplish these goals. I remember literally folding rags, cleaning rags in the basement of our home on Friday nights with a bucket of Slurpees my dad would go pick up, and all of us kids would get thousands of cleaning rags dumped on the floor in front of us, and we'd fold them and they'd get put in the back in the bags for the staff to use on Monday or whatever it was. And as they went through their entrepreneurial life cycle, we'd have motivational tapes playing in the car, and we'd have posters on the wall of attitude and mindset.
No kidding. So your parents were strong, man.
They really planted that seed, and it's not that they understand oil and gas or geomechanics or anything like that, but any entrepreneur has got a different thing inside of them, and it can go from one field to the other, from a decade to decade, and a lot of lifelong entrepreneurs change tacks throughout. Greg was the American engineer, Eric was a British engineer, and Brad was a Canadian geologist. So these guys came together somehow, some consulting gig at one point in their lives, and then eventually decided to put together a service company. But they gave me a lot of opportunities to learn and grow, and that involved mini-frac testing in these coal seams. And we would take a horse trailer out to site with a gigantic, 2,000-liter drum in it with a sight tube and a tape measure behind it. And I would stand in this horse trailer while we used our pressure washer pump to create these downhole fracs. And I remember a talk one time that Mr. Bell gave at whatever the Coal Bed Methane Society was at the time, because these acronyms change all the time with the smaller groups. And he was basically demonstrating how when you inject fluid into the ground, take a mop and turn it upside down and poke that stick into a bucket. When you inject fluid in the formation, you're poking a stick into a bucket. You don't know what that bucket sees. You don't know where that fluid goes, all these things. So anyway, even though we were running these tests and providing that data, he wasn't ignorant to the reality of what's happening downhole. But when you wait a year to get the data, and it turns out that there's 2 samples in that report, and it costs nearly $1 million to run the mini-fracs, plus the core collection, preservation, analysis, all the things that are involved with coming up with the full picture of that geomechanics puzzle, it's not a good taste in your mouth. And those 2 samples were from within 1 meter of each other, elevation-wise, in the same wellbore. So essentially you've done nothing except lose a year and learn how not to do it. So as I realized that this was a terribly inefficient process, I kind of got a little upset and talked to my bosses and said, hey, there's better ways to do this. Why don't we look at this and look at that? And I had a concept introduced to me by one of the consultants working with our company. He gave us a book about pressure meters. And I started to learn about pressure meters, and I found a geotechnical group in Eastern Canada that could provide the technology, but it's a different borehole size, and that one didn't have high pressure capacity, etc. And I couldn't get my boss to commit to trying it.
Yeah.
So that idea never left my head, and of course I knew about mini-fracs, and I understood a lot about the lab processes and shear box testing for things like UCS cohesion and friction angle measurements with the more Coulomb stuff going on there. And I talked to a bunch of different PhDs in the industry and said, hey, what about this, what about that? If we took this idea and married it to that idea, would it be a suitable equivalent data set? And they all said, definitely. The injection pressure for the steam chamber that was living underneath this caprock had been pressurized to the point where it did breach the caprock, and the entire thing exploded, sending trees through the air like missiles. Luckily, it was in the middle of nowhere, nobody was killed, but it could have very easily been a catastrophic loss of human life. So everybody in the oil sands was certainly aware of that, and
Wow.
really began sharpening their pencils on their geomechanical models and understanding what was actually going on. And this was a large company it happened to, so they weren't slouches. They had done their best, I guess, but apparently wasn't enough. And, that wasn't necessarily poking me in the ribs as to why we needed to take action, but it was when I was a client of the process that led to that I realized firsthand. I'm the kind of guy that I'm just stubborn, and I need to see things for myself a lot of times. And when I experienced that pain of that process myself, I realized, this is why people don't actually have these measurements. It's way too expensive. The process takes way too long, and it's terribly inefficient, because even if you had 100 samples come back in your report, we were still looking at a side-eye glance at the data saying, do we actually believe this? Because it's a disturbed piece of rock. Basically, the intelligent packer process is that of loading and unloading the wellbore wall with force, which is done through a membrane. Given that the foundational tool is a pressure meter, you've got essentially an instrumented packer on board. So you load the wellbore wall with force as you inflate this balloon, and you've got caliper arms inside of that balloon that are measuring displacements. The tool measures displacement and pressure, which in the rock translates to stress and strain. So a physical direct measurement, which can be used to calibrate the dynamic measurements coming off of a sonic, because you have to take those dynamic values to static all the time, and that's calibrated to what? It's calibrated to X value for a certain rock that they know the velocities through. It's not necessarily that rock at that depth at that location, but all of our tests are obviously the in situ condition of that rock, that location. So the intelligent packer is going to load the wellbore wall with force and unload, and you run through this loading, unloading cycle many times. How are we going to do this when we only have 100,000 barrels to play with? And if we can create a fracture without needing to use any of that horsepower or fluid to overcome those initial breakdown requirements, then in theory you give that frac a head start on actually penetrating deeper and deeper in the reservoir.
Wow.
So it is absolutely an application.
Wow, that's interesting.
That is fantastic. That's very interesting. Yeah.
Thank you. But believe it or not, Alberta, which is essentially Texas North, does not have a publicly accessible test site. It's ridiculous. It's a laughing joke. But that's changing, apparently. We'll see when it happens. Obviously, people say a lot of things, and politicians will stand in front of a podium to say this is what we're going to do for the people and for the companies trying to help and make a difference.
Wow, that'd be cool.
It would be game-changing, but that's probably still a couple of years away, 3 years away.
Yeah.
That was announced, I think it was last summer that was announced. But if you don't have one of the big guys closely knit into your process, it's going to be tough, and it's going to take a long time. And that's been part of our challenge, absolutely, since day one. We had small local investors involved from the beginning, and they've been incredibly supportive, and that number's grown and grown and grown as far as the number of people that are backing us up north. But we got incredibly fortunate in 2017 because Saudi Aramco did hear about our technology, the first prototype for shallow applications only, and they got involved and gave us a contract that we've been executing on for the past 5 years. Because we are using a different process to understand how much load that rock can take when you compress it by indenting that cone into it, the output that UCS name no longer applies because it isn't unconfined. And when you have somebody who was raised on shreddies their whole childhood, and you tell them they're going to start eating yogurt and granola, well, everything is still shreddies in their mind. So when you've got geomechanics PhDs looking at a data set, everything reverts to what they know about the process they used at their former employer's office, and that came up with UCS. And it's a difficult concept to to think about a physical process that isn't the same as what you've been raised on. But what we showed is that by applying our measurements, you would see where you have the strong or the weaker rock. You would see where the stress field changes as far as the magnitudes and potentially orientations. And then you could change the locations of those perf clusters. And if you take 40 clusters down to 30, but they're in the right spot, now what happens? You hit the sweet spot where your frac will propagate. You maximize that SRV.
Stimulated rock volume.
Exactly. And now you actually bring in more hydrocarbons, making you more money with fewer stages. Maybe you pump the same amount of sand and water through those fewer stages, maybe not. So you could potentially save water by reducing the number of stages. But knowing where to put them is the key. That's the crux of the problem. Where do you put these damn stages?
Yeah.
Well, we can show you that by taking the measurements along the horizontal. Now, another factor that you're going to love in that output, beyond seeing 23% more gas, and again, it's just a simulation. We all know about models. But the frac gets bigger in those stages that exist, that remain. Now, when the frac gets bigger, the drainage area increases. You move the next well by 500 meters because you don't want to have a collision. That frac gets bigger. You move the next well 500 meters. By the time you get to the edge of the pad, you drop a $10 million drill. You no longer need the same number of wells to drain that particular
SRV.
Area. The same volume. You have to do your job. You have to be the one to do your things. You have to be the one to make it happen in your life, whether it's getting to the gym, getting to the range, whatever you got to do it. Don't rely or wait for someone else to push you to make it happen. If you need to do something or want to do something, then do it. There's just no way around that. If something's going to happen for you, you're going to be the one to do it. But I had a life-changing event in 2015, and I nearly lost my life. And that taught me a lot of things, but one of them was that every day above ground is a good day. That's probably the one that I think about the most. Every day above ground is a good day. You don't know when it's your time. You do not have any control over when that bus is going to go by and you weren't paying attention, especially nowadays when we're all looking at our phones. But it also taught me a lot about fear and the power that fear has over us. You ask about why hasn't the industry done things like this? Well, part of that, you work for an operator, well, you tell me, why haven't you tried these new things? It's fear. It's fear of the unknown. It's fear of failure. And that holds all of us back every single moment of our lives if you let it. It's there.